The Genesis flood is not just an unusually long rainstorm as most imagine. As we'll see, rain was a readily observable effect of much more violent causes far below the surface. The waters of the Great Deep were the true source of energy. This energy was stored in and released from the supercritical water in several ways. First, let's discuss supercritical water a bit more. What is the supercritical phase? Boiling water will remain at the same temperature of 212 degrees Fahrenheit at atmospheric pressure. Apply more heat and it will simply boil more rapidly. However, the water temperature will not change as long as the vapor produced is allowed to escape. Place a cap on the container and both the pressure and the temperature of the water will now increase. Since all mass within the container is trapped, density of the vapor increases while density of the liquid decreases. Eventually, the density of the gas and liquid become equal. Microscopic droplets are suspended in the midst of the dense high-energy gas vapor. The potential energy stored in the water at this state is tremendous. The huge surface area of the droplets allows supercritical water to quickly dissipate added heat by evaporating all at once. Rather than increase in temperature, heated supercritical water, if allowed, will simply expand rapidly, converting heat into kinetic energy. Liquid water exposed to heat can only cool through evaporation off of its surface area. However, surface area of normal liquid water is limited and therefore the temperature of the liquid will increase because the surface area is small. Because the liquid surface area of supercritical water is enormous among trillions upon trillions of tiny droplets, supercritical water can evaporate many molecules simultaneously. If allowed, supercritical water will simply expand rather than increase in temperature. If more energy is added, the expansion accelerates. So that is some cursory information on supercritical water. But another form of energy stored in supercritical water was electrical ionization energy. So what is ionization energy? Under normal conditions in an open environment, occasionally molecules of a fluid will collide. When they collide with enough energy, the molecules will break apart into charged ions. This happens rarely with water in an open environment. A closed and pressurized environment forces molecules closer together, increases fluid pressure, and makes collisions more likely. Increasing temperature causes the molecules to vibrate faster. The closer proximity and increased movement causes more collisions. This causes ionization of the water. If pressure suddenly drops, the charged particles will rapidly seek an opposite particle. The sudden and multiple ion collisions back into whole molecules releases much heat into the fluid. Twice a day for centuries, the tidal pull of the moon, and to a lesser extent the sun, would have lifted and done work on the Earth's crust. This would have increased the thermal and ionization energy of the waters of the Great Deep, causing it to eventually become supercritical. Remember what happens when heat is added to supercritical water and allowed to expand. Supercritical fluids are studied today mainly for their great potential for dissolving minerals. The greatly increased energy of fluid molecules impacting against a solid will break up and dissolve the solid much more than would normally occur with less extreme conditions. Centuries before the flood, tidal pumping had heated the subterranean waters to a temperature above 705 degrees Fahrenheit, and the water became supercritical and began to dissolve the more soluble minerals in the chamber's floor and ceiling. For centuries, supercritical water dissolved the more soluble minerals in the granite and mantle, creating porous openings in the rock above and below the subterranean chamber. Once elements like sodium, calcium, carbon, chlorine, oxygen, and magnesium were released by the supercritical water from the solid structure of the rock and into the solution, they were free to combine, forming new molecules like limestone, dolomite, and salt. These minerals eventually precipitated out and heavily blanketed the chamber floors of the Great Deep. In the granite, this resulted in shifting of the embrittled material as tidal effects stretched and heated the granite pillars. Due to gravitational settling, denser trace materials like iron and nickel naturally collected in the lowest portions of the pillars of the crust. The porous region of the mantle that was dissolved by the supercritical water formed the density boundary today known as the Mohorovicic discontinuity, or the MOHO. In the oceans today, thick plumes of hot, supercritical water known as hydrothermal vents or black smokers are still escaping from the porous MOHO beneath the ocean floors in places. The high heat and pressure of the supercritical water still flowing from these vents shows that the flood event was relatively recent. In the years before the flood, as pressure increased in the waters under the crust, the compression which maintained the seal in the granite was replaced with tension loads as the pressurized water below expanded and began to stretch the crust. While granite has rather good compression strength at 23,000 psi, it is very weak in tension, only around 600 psi. Eventually it failed and a crack developed at the surface and in seconds raced completely through the 60-mile thickness to the pressing waters below. This crack raced across the crust, circling the globe twice in about 2 hours, covering around 46,000 miles. The record in Genesis 7:11 can be taken literally when it states that all the fountains of the great deep burst on the same day. A tension crack in granite will travel at nearly 3 miles per second. In this case, the crack propagated at this speed in 2 directions. The starting point of the crack appears to have occurred near what is now the Arctic Circle, somewhere in the East Siberian Sea. As stated before, the mid-ocean ridge is a scar on the ocean floor that roughly traces a great circle path of the crack that opened up in the granite shell above. As you are looking at this map, remember that hydroplate theory proposes that the continents as we know them today have slid to their current locations and thus have covered some sections of the mid-ocean ridge. This explains why the North American Rocky Mountain chain is bolstered by multiple adjacent chains and so appears much thicker than the narrow chain of South America's Andes. Notice that the mid-ocean ridge bisects itself at right angles in the Indian Ocean. This marks the point where one end of the crack intersected the other, which had already passed by. Since the 2 ends of the crack traveled at about the same speed, we can measure back equal distances to find the approximate initiation point. Now superimposing the original crust above the map, we can clearly see the mid-ocean ridge bisects itself by running the animation forward in time. The end that raced from the Indian and Pacific Ocean side reached the T first. Therefore, the other end coming around the African side abruptly stopped at that location. Note that this is much easier to see using a spherical globe rather than the distortions that come from a flat map. You can experiment for yourself with Google Earth's path tool by tracing the continuous path starting with the T in the Indian Ocean along the mid-oceanic ridge until you loop back to the T. Google Earth will tell you how long the path is, so simply divide the distance by 2 and then right-click on the path you just made and select the Show Elevation Profile option. A graph will pop up and then simply move the elevation bar to the halfway distance that you just calculated. An arrow will trace the path and show the spot on the globe. See what initiation point you get. Next time you hear the dogma that the mid-ocean ridge is a result of seafloor spreading, notice that usually only the Atlantic or Pacific ridges are given as examples. Now ask yourself how the typical seafloor spreading scenario fits over the mid-ocean ridge in the Indian Ocean. How is the material moving away in 4 directions, and perpendicular to itself? How do the forces produce spreading here, and not also produce spreading up here? Why does the spreading suddenly stop at the crossing ridge, and not continue through? If material is moving in these 2 directions, why are there no signs of compression or trenches in this area? Or does hydroplate theory offer a more reasonable explanation for this feature as we just saw? You may wonder why the crack did not stop moving once the water pressure was first relieved. It is because the subterranean waters were all connected and therefore at basically the same pressure. The speed of sound in granite is much faster than in water, and pressure waves in any material can only travel at the material's speed of sound. So the granite crack always raced far ahead of the water's pressure drop. Imagine you are looking at a cross-section of the granite where the crack passes by. Now we will pictorially see why the crack did not stop moving once the pressure was first relieved. Again, the subterranean waters were all connected and at the same pressure. The speed of sound in water is only about 1/3 the speed of sound in granite. So the leading edge of the crack always raced along the surface far ahead of the water's pressure drop. So you'd see the granite separate long before you felt the drop in the water's pressure. We speak of a crack initiating, but because the continents were so large and had been stretched over thousands of miles, there was a great deal of elastic strain in the plates. This thinned the plates slightly, just like a rubber band will thin as it stretches. And like a stretched rubber band, the granite stored strain energy like a spring waiting to snap. So once the crack sped through the granite, the tension in the plate was relieved, so the plate snapped back like a rubber band, breaking and quickly producing a gap a few miles wide. Then the high-pressure supercritical water jetted violently out of the rupture. Again, Genesis 7:11 records the events of that day. In the 600th year of Noah's life, on the second month, on the 17th day of the month, on the same day, all the fountains of the great deep burst open, and the floodgates of the sky were opened. This is the first time in the Bible that any event is recorded so precisely down to the day. They obviously witnessed something much more than a heavy rainstorm. Very literal fountains of the deep shot up, accelerating high above the atmosphere at hypersonic speeds. Some scoff at the idea that water could be ejected so high. However, high-speed vapor plumes have been observed presently on the moons of Enceladus and Europa. These examples give a glimpse of the much more powerful forces that Earth would have produced. The blue arrows represent the pressure of the waters of the great deep due to the weight of the granite above. For every action there is a reaction, so for equilibrium or no movement, the force of the blue arrows must equal the force of the red arrows, which represent the reaction force of the mantle pushing back. As we progress, pay attention to the blue and red arrows. The pressure of the water near the crack would drop. Since the pressure in the middle of the granite plate would be very high, while the pressure at the crack would be very low, this would cause the edges of the unsupported granite to bend down, creating a tapered nozzle at the crack. Remember, most of the weight of the granite was carried by the pressurized waters. As the subterranean water was escaping, pillars had to carry a greater load because the subterranean water pressure was dropping and therefore carried less of a load. Eventually, the pillars, which were brittle and porous from centuries of contact with supercritical water, failed from the added weight and began to crush and break up into fragments, causing enormous earthquakes within the plate. Every time a hydroplate oscillated down, it partially closed the nozzle-shaped edge of the plate. An entire ocean of escaping water was then forced to slow down, producing what is known as a water hammer. Water hammers can cause pressure spikes many times the initial pressure in a flowing fluid. Every time this happened, velocities at the crack would have spiked as well. Whenever a liquid or gas flows over a flexible surface, the flow can induce flutter in the surface. This is easily seen in a flag that is flapping in a strong wind. Hydroplate theory poses that during the beginning stages of the flood, as supercritical water rocketed out from under the plates, the flow of fluid under the plates, in combination with seismic waves from the buckling and crushing of these pillars, induced flutter oscillations in the granite plates which lasted for several weeks. Return oscillations lifted the fractured pillars from their bases, and then slammed them back down into the mantle, producing more vibration and fragments which were swept into the flow. As the edges of the plates oscillated down, flow was restricted while internal pressures spiked. As the plate edge oscillated back open, the tremendous pressure was released, so the fountains pulsed in tune with the plate flutter. It is hard to imagine granite 60 miles thick bending, but consider that the area of the plates was thousands of square miles across, so on a continental scale the plate thickness was tiny. Remember that many of the views you'll see here are out of scale so that we can see the concepts. For example, a more scaled view across the North American continent before it was compressed and thickened would look like this if the granite was 60 miles thick. When you consider that a plate was mostly suspended by a fluid foundation, it is not difficult to imagine bending and flutter in the rock crust. At the point of the crack, pressure dropped from 372,000 psi, or higher due to water hammers, to near atmospheric conditions. Similar to the phase change of a propellant like gunpowder, water changes phase and expands to a gas, increasing volume by 1,600 times. The phase change of supercritical water to gas was similar, but much more energy was involved. Because of this, the volume of expansion was much greater. Remember, the supercritical water contained tremendous stored energy, so while the pressure drop caused some expansion, it also began a chain reaction which released all its stored energy. The sudden pressure drop caused ion collisions, which added heat to the fluid, and because supercritical water's microscopic droplets had almost infinite surface area to evaporate, the added heat almost instantly converted to kinetic energy as the water expanded from the base of the crack. This chain reaction continued to occur all along the flow, which accelerated the fluid from the base of the crack to far above the atmosphere. With no atmosphere to produce drag, tremendous velocities were possible. Finally, in the initial stages of the flood, the waters of the Great Deep were subject to heat from nuclear reactions that appear to have occurred in the granite as it flexed and fluttered above the flow. In objection to Walt's estimates of temperatures of the supercritical water under the crust and the energy estimates involved, Some apply simplistic heat transfer equations to the volume and mass of the atmosphere, and then declare catastrophic boiling or vaporization of all life. Others also argue that the hypersonic speeds of the fountains would have pulled the atmosphere up along with it and stripped it from Earth's surface. So is there a heat problem with this theory? If all this energy was released during the flood, would Noah roast? Well, I'd say not likely. Just because high temperatures and huge amounts of energy are involved does not mean everything nearby would be dead. Sometimes a picture gets this point across better than a technical discussion. That flame is probably about 1800 to 2000 degrees Fahrenheit. My hands are less than an inch away and could easily have stayed at that position till the bottle ran out of propane. So first consider that this is a scenario that involves directed energy. Yes, there was tremendous energy involved, but where was it headed? I think some of the confusion arises by immediately simplifying the problem and not accounting for everything happening throughout the entire scenario presented by hydroplate theory. Consider that when a fluid expands, it cools greatly. So by the time the initially high energy water directed far above the atmosphere fell back as heavy rain, any remaining heat would radiate into space, which is a huge, almost infinite heat sink. Remember the picture of my hands just an inch or so beside the torch. Air is actually an insulator, a very poor conductor of heat, especially when it is stagnant. Nearly all forms of insulation, from fur to your coat to your house walls, rely on still air to be effective at preventing conduction of heat. The great speeds of the fountain's flow mean that there will be little time for heat transfer with the atmosphere as it raced past. Like my hands, Noah was located beside and away from the fountains, and the air in between would have protected from extreme temperatures. Consider too that the atmosphere is like a wide, thick blanket for Earth, and it has tremendous inertia that would have to be overcome for it to be stripped away from Earth's gravitational pull. A focused high-speed flow is just about the worst method I can think of for imparting kinetic energy to a gas. If you question this, try an experiment. On a still, non-windy day, light a leftover 4th of July smoke bomb, then use a hose with its nozzle set to its most pinpoint setting to try to move the smoke around or out of your yard. After you get frustrated, try a slow-moving fan and then consider just how effectively a pinpoint high-speed flow moves a gas. It is a terrible method for moving a gas. Finally, consider that at the top of Earth's atmosphere, temperatures plummet to negative 150 degrees Fahrenheit and lower. So any air beside the fountains that was heated and pulled up with the flow would have a tendency to lose speed, fall away, and radiate any gained heat long before it floated back down. If interested in how this nuclear heating occurred, follow the link shown here to a presentation on the origin of Earth's radioactivity. There you'll find not only the explanation for nuclear heating, but also discover the surprising evidence of plate flutter, how chondrules formed in meteorites, how heavy elements were produced during the flood, and how accelerated radioactive decay occurred, which produced the parent-daughter ratios which so many mistakenly think is proof for billions of years of time. For now, we will skip this subject as it would greatly sidetrack our review of hydroplate theory. Just realize that this nuclear heat produced within the plates greatly pressurized the supercritical water that had eaten into and was now partially constrained within the porous regions of the plates. Because the upper half of the plates were still solid undissolved granite, this pressurized water could only expand laterally and down through the porous channels. The expansion of supercritical water within the openings quickly fractured the lower regions of the plates. These dislodged porous fragments quickly fell into the pulverizing flow and were accelerated up into space. This process quickly eroded and thinned much of the originally thick plates. This would explain why the estimated 60-mile thick plates were eroded to today's average of about 30 miles thick. The flow under the plates produced extreme velocities high enough to launch materials beyond Earth's gravitational pull. These objects are observed in our solar system today as interstellar dust, comets, asteroids, meteors, and trans-Neptunian objects. Let's discuss some common traits these stellar objects share with Earth. Comets are about 38% water ice. Asteroids are loose collections of smaller rocks loosely held together by water ice. Both contain salt and silicates, which make up about 95% of Earth's crust. They also contain crystalline silicates, which require uniform temperatures of above 1300 degrees Fahrenheit and slow cooling under pressure to grow. How could this happen in space if space is the origin of these objects? Space is an environment of no pressure and near absolute zero conditions. Limestone and clays are found which require a body of liquid water to form. In 2011, the mineral cubonite was reported in Comet Wild 2. Cubonite only forms in scalding hot water between 122 and 392 degrees Fahrenheit, but comets do not reach these temperatures even at their cores. Comets, asteroids, and meteors contain olivine, which is a common mineral of Earth's crust and mantle. Olivine is also concentrated with iron nickel in some meteors. Iron nickel alloys found in meteors contain the unique Widmanstätten pattern, which again means the material formed under uniform temperatures of at least 1300 degrees Fahrenheit. The conditions in the Great Deep easily explain these surprising findings. Finally, and most perplexing, organic compounds, complex molecules, and materials like amino acid and even bacteria are found in these objects. Studies of interstellar dust scattered throughout the inner solar system near Earth's orbital plane find this, quote, dust actually matches the spectral properties of complex structures like frozen bacteria and cellulose. This has led some scientists involved to wonder if these materials somehow seeded and began life on Earth. Considering that their origin hasn't been explained in the ideal environment of Earth, it is baffling to think how these could ever form in the unfriendly conditions of space. For example, what protected these delicate structures for millions of years while fully exposed to harsh solar rays? Traditional explanations for these complex organic molecules are severely lacking. Of course, without question, the Earth's surface has the highest known concentrations of these familiar products of life. Where else does something like cellulose form and thrive? Often these bodies are explained as leftover building blocks of our Earth. So while there is much speculation over the origin of these objects and their content of trace organics, the evidence strongly suggests that we are standing on the source. Although rather large, asteroids like comets have low density and are weakly held together. Vesta is one of the largest and is almost big enough for its gravity to make it spherical. Ceres is the largest asteroid and makes up 1/3 of the mass of all asteroids combined. It has just enough mass to pull itself into a roughly spherical shape. The mass of all known asteroids combined make up only a small percentage of Earth's mass. So asteroids are probably not the fragments of a planet that completely exploded, as some people initially thought. Since asteroids are actually made up of many smaller rocks, dust, and water ice, it is not so hard to imagine them being ejected from Earth via mechanisms we just covered. As these particles traveled farther from Earth, their gravitational sphere of influence increased. So larger rocks gravitationally attracted more and more smaller rocks into their vicinity, which caused their gravitational spheres of influence to grow even more. Eventually, these mergings became comets and asteroids. Those that did not merge to become comets and asteroids are today's meteoroids. Some asteroids became so large that they maintained their gaseous atmospheres for much longer, which allowed them to sail on the solar wind past Neptune's orbit, becoming trans-Neptunian objects or TNOs. TNOs share many characteristics with asteroids. Both measure exceptionally low densities of around 2 grams per cubic centimeter. Both are often reddish in color due to the surface rocks containing iron oxide, oxides which likely formed due to the presence of water launched with the rocks in the fountains of the deep. When the mass of all TNOs is considered, then the percentage of the material ejected from the flood jumps to around 3% of Earth's mass. This line of evidence is one of the main reasons for changing hydroplate theory's estimated initial crust thickness to 60 miles. I say special conditions are required to form these objects because the gravity of small objects is tiny. Asteroids and comets would never accrete if the trajectories of objects and the angles of impact were random. Even landing a small, carefully guided space probe on a large asteroid or comet is incredibly challenging due to how low the gravity environment is. If traveling at even slightly differing speeds, impacts in space result in further fragmentation and breakup of particles, which will never return to each other. Just so conditions are required for accretion. All of these special conditions are accounted for and explained by the hydroplate theory. Items must be traveling at the same relative speeds and along the same trajectory. The presence of gases during this process greatly aids in aerobraking the inbound components, providing the best possible conditions for successful accretion. Many asteroids surprisingly have moons like Ida and its moon Dactyl. Capturing a moon is incredibly difficult for the same reasons we just discussed. However, moons would be expected if asteroids originated from a stream of particles with shared velocities and direction. Many TNOs have moons as well, as hydroplate theory would expect. Some TMOs even orbit each other at great distances. Another scenario which requires the unique conditions that only hydroplate theory seems to be able to provide. Some large asteroids have gently connected with their moon, like Itokawa. As stated, it is difficult to do this even with small, precisely controlled spacecraft. When the large size of these fragile bodies is considered, it is hard to imagine how this occurred randomly in space with no gaseous atmosphere to provide aerobraking. Notice that this picture of the surface matches what hydroplate theory predicts. Asteroids are not angular shards of a broken larger planetoid. They are low-density flying rock piles loosely held together by water ice. The rocks are well rounded. In this picture, some rounded boulders are over 150 feet in diameter. High-velocity flow produced many rounded objects discovered on Itokawa. Hydroplate theory readily explains these findings. Meanwhile, researchers like Donald Yeomans from NASA Jet Propulsion Laboratory realize the problem and currently seem stumped by what is observed due to their evolutionary viewpoint. Recent detailed explanations show comets have similar makeup as asteroids. In fact, some asteroids are categorized as both an asteroid and a comet since they sometimes vent gases and dust producing familiar tails. Comet nuclei like the one shown are low-density, dirty snowballs composed primarily of water ice, dust, organics, and curiously again, rounded boulders. The surface of Comet 67P has layer upon layer of large rounded boulders at least 10 feet in diameter. This would not be expected if these fragments were due to collisions in space. They should be jagged and angular. Of course, rounded boulders is exactly what is expected if these fragments were once exposed to and tumbled in an extremely high-velocity flow as they were ejected from the fountains of the deep. This is the same mechanism by which river rocks are rounded, albeit these large, quote, dino eggs were rounded much faster. Here's a close-up of a crater where hundreds of these rounded 10-foot boulders are exposed. Here again, rounded boulders are observed on the peanut-shaped comet Hartley 2. Like the subject of the origin of Earth's radioactivity, the hydroplate theory's full explanation of the origin of comets, asteroids, meteors, and TNOs would take us on a long bunny trail that would distract from this overview, so we will have to leave this subject and move on. A more thorough, in-depth presentation of this subject may be found by clicking on the following link displayed. To continue with the hydroplate theory overview, please click the following link to the next segment.